He needs to stop. And so mean absolute value is a little bit different than just when we find a mean, because what I always think of when I think of mean absolute value is I think, imagine that we had a student who either got A's or they got F's. Like there was nothing in between. They either got an A on something or they got an F on something. What is the average grade of an A and an F? A C. A C would be right in the middle, right? So if we said, oh, they're a C student, because when we average their A's and their F's, they're right in the middle there at a C. But really, they didn't get a C on anything, right? There were no C's in their grades. It was because they averaged A or F. So if I were going to sit down with that student and have a discussion about their performance or how they were doing, I'd want to figure out, why are they getting only A's and only getting F's? Like, is it they're getting A's on all the quizzes, but they're getting F's on the homework because they're not doing it? Is it because they're getting A's on the homework because they're doing it and getting some help at home, but they're getting F's on the quizzes because they don't really understand it? That's a little bit different than if I had a student who always got C's. Their average grade is the same, but the student who always gets a C, I'm going to know, you know what, they're doing the best they can. They don't quite understand it. They're getting a C on the homework. And then it makes sense because they're getting a C on the quiz. Their grades are consistently C's. So their average is the same. But when we look at what their actual breakdown of their grades are, it's different. Somebody who gets A's and F's compared to somebody who gets only C's. Landon, I want you to move a whole desk back. So when we talk about mean absolute deviation, what we're talking about here is the average, or I'm sorry, mean absolute value, sorry, the average distance between each data value and the mean. Okay, the average distance between each data value and the mean. So, a couple different facts, characteristics about this is that sometimes you'll see it abbreviated MAD. What's the MAD of the data? And that stands for that mean absolute deviation. And what it does here is, what its job is to tell, it tells how much our data varies. So again, if I think about my person who always got C's on every single paper compared to my person who got A's or F's, that person who got A's or F's, their grades vary a lot more than the person who got C's all the time. So looking at absolute deviation, or I keep using that word, absolute value, mean absolute value, oh, you know what, I wrote it wrong up there, that's why I keep using the word deviation, because it is supposed to be mean absolute deviation. Sorry about that. You know what? It was Bryson's fault, because I wrote mean absolute and he said value, and I was just like, yeah, I'll go for that. But that was wrong. It was deviation.
I don't even have an eraser. You expect me to erase all that?
I spelled that.
It's not my fault that I'm stupid.
Deviation. Mean absolute deviation. That's why I keep saying that, too. I was like, why do I keep saying it that way? Because that's how it's supposed to be, Bryson.
We have to erase all that.
No. Just the word. It wasn't mean absolute value. It was mean absolute deviation. So that's the only word you need to change. All right. So when we think of an example, usually when we go down to examples, we actually do a sample problem or show what that's going to look like. But we're not doing that on this because it's a really lengthy process. We don't really have room right there. But what we do want to know is the closer to 0 the MAD is, the less the data varies. Because the what? Yeah, that would have been MAB. So the closer to 0 that our mean average deviation is, that tells us that the data doesn't vary as much. And so if we're going to say something is the average, the reason we're finding an average is because we want to say this is about what happens every single time. But if we get these really wild numbers that change a lot, then it's not really a good measure. So again, if we think about those students, my student who always got a C and I said their average was a C, chances are if I gave them a homework assignment, they were going to get a C. My student whose average is a C, who either gets A's or F's, if I give them a homework assignment, it could be an A or it could be an F. I'm not sure. I can't really predict that as well because I'm getting more variation in their grades. So under non-examples, we're going to write this down and we're going to talk about it as we do an example here in a minute. But a non-example of when we do the mean absolute deviation is, some people, is if we are not taking absolute values of the difference. Now, I know right now you're like, that doesn't make sense. I don't even know what she's talking about. That's fine. We're going to come back and talk about it after we look at some examples.
You mean put this in our,
Nope, and you know what? We are actually not going to put that in your journal just yet or in your notebooks just yet because we do have these two things down here that we really need to see an example to know what they mean. So we're going to wait till we do an example and then we're going to put them away. So we're just going to set these aside for right now and we're going to talk about mean absolute deviation and then we'll come back and put that away in a little bit. So going back in your journal here, and we're looking at steps. How do we find mean absolute deviation? Well, it's got a lot of little keywords in it that we've seen before, like mean. We just did something with mean, so we know mean means average. And then what Bryson jumped to there, where he said absolute value, but we said absolute does mean absolute value. We have seen that before, so it's got that little root word in it. And then that deviation is kind of a new word, but it just means that how much is it varying? How much is it changing? So we're going to have some mean in here. We're going to have some absolute value in here. And we're really looking overall at how it changes. So our first step, when we have some data and we want to find the mean absolute deviation, our first step is that we are going to find the average of the data. So if we're going to say how much does our data vary from the average, the first thing we have to do is find out what the average is. So that would be our first step. We find out what the average is. Our second step then is, once we know what the average is, we want to know, well, how much does each piece of data, how much different is it from the average? How close is it to the average? So my next thing that I have to do is find the difference between the average and each piece of data. That means all the little numbers that I added together to get the average. And so when I do it, what does difference mean? What was that keyword difference? What operation, Jocelyn?
Sum of subtraction.
Subtraction, good. So when I do subtraction, sometimes I might get a negative number, and I don't want negative numbers if I'm talking about a distance or an absolute value. So once I get that answer, what I have to do then is take the absolute value. If I'm talking about how far is something from the average, remember distance has to be positive. If I'm talking about how far away I am from Austin, I can never be a negative distance from Austin. Like, even if I went on the other side of him, I'm still 2 feet away from him. I can never be a negative distance away from Austin. So that would be like fourth dimension crazy world in a science fiction book that I could be a negative distance away from Austin. If I walk towards him, I'm still a positive distance away.
And then when she's like right up on top of him, she's 0.
I'm 0 distance away. If I was standing on Austin's shoulders, if we were stunting for cheerleading and I was standing on Austin's shoulders, I would be 0 distance away from Austin. And then if I hopped down when I fell off and I went backwards that way, I'm still a positive distance away from him. I'm still 2 feet away from him. So it doesn't matter which way it is, it's still going to always be a positive distance. All right. Okay. So distance is always going to be a positive number. That's why we take the absolute value. Once we have all those distances, my next thing that I need to do is I need to find the average of the distances. So now I know how much each piece of data, how far away it is from that goal, which our goal was our average. Now that I know how far each piece of data is from that goal, I need to find an average of that.
She's copying the note. She's a cheater.
Okay, and then my last thing is that I need to make sure the closer to 0, the less the data varied. No, we got to do some examples of this because that's a whole lot of stuff that we have to do without a lot of information about it.
Okay. Kira, what is that, Pete? Oh no, it's Mountain Dew. It's Mountain Dew. Oh.
Okay,
It's like Kira said yesterday.
so looking here at an example, we've got two basketball players. We've got Terry and Chris, and this is a little this is a little chart to show how each of them did. Okay, so Terry, this is the baskets per game. So they've each played 8 games because there's 8 basketballs in our data that we have. And so Terry scored 9 baskets 4 times, and he scored 10 baskets 4 times. So the first thing that we need to do here, and I'm going to label this as my example. I should have done that first. Is that we're going to look at Terry's score. The first thing we need to do is find the average of the data. So if we want to find the average, that means we have to take 9 plus 9 plus 9 plus 9, because the 4 games he scored 9 points, plus 10, plus 10, plus 10, plus 10, because 4 games he scored 10 points. Write it down. So, all together there, if we do 9 times 4 is 36, 46, 36, 46, 56, 66, 76 points altogether, or 76 baskets. Divided by, how many pieces of data did we have there? Divided by 8. And so 76 divided by 8, if I type that into my calculator, 76 divided by 8 is 9.5. So on average, Terry scored 9.5 baskets per game. Bryson?
You don't have to use a calculator because if 9 has is even the same amount as 10, all you gotta do is split it in half. So
Yep. Perfect. I'm glad you saw that. That was good. Okay. So that was my first step. I found the average. My second step now is I have to find the difference between the numbers that he actually scored and the average, which was 9.5. So I'm going to start up over here because I'm going to make a column here of the 4. There's his 4 9s. There's his 4 10s, right? This was all my data that I had. The next thing I have to do is subtract the average from that data. So the average is always the same. So this whole column is going to be minus 9.5, minus 9.5. What we have to do in order to get the mean absolute deviation. So all these steps here are steps that you will have to show on the homework because this is what we have to, these are the steps we have to do in order to get this answer. It's not like a magic, oh, I'm just going to get this answer. So if I start subtracting that, okay, if I'm just going to start subtracting that, what's 9 minus 9.5 is negative 0.5. 9 minus 9.5 is negative 0.5. So the first 4, because I'm subtracting the same thing every time, they're always going to be negative 0.5. The next 4, 10 minus 9.5 is positive 0.5. Well, I'm doing this subtraction right here. 9 minus 9.5. I've got more negatives than I do positives, so I'm going to have negative 0.5. Here, I've got 10 minus 9.5, so it's going to be positive. No. If I have $10 and I spend $9.50, do I still have $1?
No.
I only have 50 cents left over.
It's
10 minus 9.5 is 0.5. That's it.
Wait.
Yes.
It would be 0.
What would be 0?
The answer. Wait, when did you add those all up?
Yep.
So it would be 0.
So we're going to add all of those together.
It would be 0.
Wait, it wouldn't be 0 yet. You're right, it would be 0, but he didn't always get the exact same amount of points because we haven't done this last step. And we even said on our Freyer model, this is a mistake, not taking the absolute values. So our next step is, we don't just want our answer there, we want to know the absolute value, because we're wanting to know how far away from the mean is each number. Not positive or negative, just as a distance. So I would have 0.5, 0.5, 0.5, 0.5. All of these would be 0.5 because the absolute value is just the positive of the number. Gotta do that.
No, they're not negatives. They're positive. You add them together.
Okay, so this next column, when we did our equals, this was our difference. And then this was our absolute value. So then my next step then is I have to find the average of the distances. So I need to add all of those up. So that would be 0.5 plus 0.5 is 1. So I'm going to have 1, 2, 3, 4. And I have to divide that by the number of numbers that I had. So how many 0.5s did I have there? 8. No. It's 0.5. 4 divided by 8 is 0.5. If I only had 4 pieces of candy and 8 friends to share it with, each person's only going to get half a piece of candy.
But wouldn't the answer would be your difference?
If you have 0 friends and 5 people.
Well, we're going to look at another one here because this one worked out nice where it was all the same. But Chris's is not going to work out as nice.
What if
Because they're all different.
Right.
What if you have 0 friends and 5 pieces of candy?
Why do you gotta be so?
All right. So, give that to me. This is the second day for you, so told you guys the other day I do not want notes. I don't want to see sticky notes. We talked about it on Friday when we were in the
What would happen if, would it be the same if you had no friends and 5 pieces of candy?
Then nobody would get any candy. All right.
But you
So, Terry's mean absolute deviation is 0.5. 0.5 is pretty close to 0, right? So Terry's is pretty consistent as a basketball player. That he's always getting really close to his average. If I say Terry averages 9.5 points per game, he's really, really close to that. So let's look now at our other basketball player, which is Chris. Okay, Chris, the first thing we have to do, again going back to this, is we have to find the average of the data. So we have to go and we have to take Chris's data here, and we need to find the average of all of those. So Chris had one game where he scored 2 points, and a game where he scored 5 points, and 2 games where he scored 8 points, a game where he scored 11, write all that down, a game where he scored 13, a game where he scored 14, and a game where he scored 15.
That's a lot.
So if I add all of those points together, 2 plus 5,
Plus 8.
oops, 2 plus 5, I can't hit it right, plus 5, plus 8, plus 8, plus 11, plus 13, it's 76, right?
You didn't do the.
I didn't get them all in there, but I did this. So 11 plus 13 plus 14 plus 15, it's 76. So how many pieces of data do I have on Chris?
8.
So I'm going to divide by 8 again. And I know this from over here. Chris also has an average of 9.5 points per game.
Purposely did that.
However, Chris's data looks a little bit different. Chris sometimes scores 15 points in a game, and sometimes he only, or 15 baskets. Sometimes he only scores 2 baskets. So he's not as like in one spot. He's kind of more all over the place. So if we want to look at, well, how much does Chris vary? We're going to do the same thing that we did up here. We need to start with the data. So 2, 5, 8, 8, 11, 13, 14, and 15. We have to start with the data. You guys should all be writing this down. If anybody's not writing this down, I'm going to check your notes when we're done here. You're going to have to come in tomorrow night after school and get it all down. Because this is its own objective. This is something you're expected to do. So if you don't have it down and then you don't know how to do it, you're going to be in a world of hurt. So then we're going to subtract the average again. And Chris's average was also 9.5. So 2 minus 9.5 gives me negative 7.5. 5 minus 9.5 gives me negative 4.5. 8 minus 9.5 gives me negative 1.5. And then I have another one of those, so I know it's still going to be 1.5. 11 minus 9.5 gives me 1.5. 13 minus 1.5 is going to give me 3.5. 14 minus 9.5 is 4.5. And 15 minus 9.5 is 5.5. 5.5. So that's my difference. But again, I don't want to add positives and negatives because it's going to look like we didn't have any difference at all when we did, so I have to take the absolute value of each of those because we're talking about distance. How far from the average is each of those numbers? So the absolute value, 7.5, 4.5, 1.5, 1.5, 1.5, 3.5, 4.5, 4.5, or 5.5, sorry.
We did it so far.
So far.
I just missed it.
So then once we have the distance, how far is each data point away from what we thought, what the average is? Now we have to take the average of those differences. So I've got to add all those together first. 7.5 plus 4.5 plus 1.5 plus 1.5 plus 1.5 plus 3.5 plus 4.5 plus 5.5. And I get that that's a total of 30. So altogether, for all those data points, Chris was 30 off from what the average was. And then how many data points did I have?
8.
So I have to divide it by 8. And I get 3.75. So when we think about who was more consistent here, if I wanted a good consistent player to pick for my basketball team, who was closer to 0? No. Chris has 3.75.
Terry.
Which one of these is closer to 0? 3.75 or 0.5?
Terry.
Terry was closer to 0.
Terry.
So even though they both had the same average, if I was picking a basketball team and I wanted somebody that if I put out there on the court, I knew that they were going to get between 9 and 10 points, even though both of them had the same average of 9.5, Terry was more consistent. I'm more likely to get those 9 to 10 points with Terry. With Chris, I might get as many as 50 points, but I might get as few as 2. So he's not as a consistent of player as Terry was. So when we're looking at mean deviation, that's what we're looking for. We're looking for consistency.